Hello aspirants, welcome back to SKD's Note. So today we are going to discuss about some important concepts of DC machines which are useful for your competitive exams such as kptcl, assistant electrical inspector and many other examinations. Okay, so here we have a DC machine, correct? So in DC machine we have DC generators and DC motor. So DC generators are further divided into separately excited and self excited. In self excited we have three more. So we have shunt generator, that is in self excited we have DC shunt generator and DC series generator and DC compound generator. In compound generator, so we have cumulatively long shunt and short shunt, differentially long shunt and short shunt. Okay, so similarly we have DC motors, we have DC series motor, DC shunt motor, DC compound motor. In this DC compound motor we have cumulative compound, differentially compound DC motors. Okay, so we'll see all these in detail in upcoming classes. Okay, for time being we are just going to study firstly DC generator. So what is DC generator? So firstly, all of you know that DC generator means to generating a DC power or energy. So DC generator is nothing but what? So DC generator is a device which converts mechanical energy into electrical energy. Okay, sir, whether it may be a DC generator or DC motor. Okay, so you require three main objectives. One is magnetic field, a conductor or a coil, okay, and relative motion between them. Relative motion between them means these two. Okay, magnetic field, a conductor or a coil. So we know that north and south poles are called magnetic fields, where this is called as what? This is called as a conductor or a coil. Understood? So relative motion between them. So firstly, the DC generator or the generator works on the basic principle. Let me explain you first the working principle. So generators works on the principle of Faraday's law of electromagnetic induction, correct? Generator works on Faraday's laws of electromagnetic induction. EMF is induced in the conductor. Okay, so an electrical generator is a machine which converts mechanical energy into electrical energy. The energy conversion which is taking place in this generator, okay, based on the principle of the production of dynamically induced EMF. Dynamically induced EMF. Understood? Whenever a conductor, whenever this conductor A, B, C, D cut by these magnetic field lines, okay, there will be an induced EMF. Okay, that EMF is called as what? Dynamically induced EMF. This induced EMF is produced in it according to Faraday's law of electromagnetic induction. This EMF causes a current flows, okay, in a circuit when it is closed. Suppose if it is open, there won't be any current. Understood? So as I said, either it may be DC generator or a DC motor. You require three what important objectives, that is magnetic field, a conductor or a coil, and relative motion between them. See sir, you can generate in either of the direction, relative motion between them. By keeping magnetic poles or magnetic fields constant, you can rotate a conductor or a coil, or else you can keep this conductor constant, you can move these magnetic fields to cut a conductor. Okay, either of that can be possible. So usually we will be fixing the magnetic field or poles. Okay, we are fixing them. So the only factor which is meant to be rotated is here a conductor or a coil. Understood? So here we were talking about Faraday's law of electromagnetic induction. So in that, generator works on the principle of dynamically induced EMF, that is relative motion between a magnetic field and a conductor. Understood? So before going to that, let me explain you how this generator getting induced EMF. So let me tell you, in generator we'll get the generated EMF, how it is working in the DC generator. So due to magnetic field, that is north and south pole, there will be a magnetic field lines. Whenever a conductor cut by them, there produces a magnetic flux. Correct? We have magnets, those are all called poles. Correct? Then the conductor is rotating at a some speed, we call it as, and it is denoted as n. This is speed. Okay, n, we say it as rotating at an RPM, revolutions per minute. For 1 minute we have 60 seconds. Okay, understood? So then we have what we have. So conductor is there. So in DC generator we can wound the coils or conductor in two ways. Okay, lap wound and wave wound. That depends upon the application you are using that DC generator, okay, or a motor. Fine. So here that conductors are denoted as Z. Okay, and how they are wound in the armature core, that depends, and how it is been wound set by area of parallel path. Okay, suppose if it is a wave winding, the number of parallel paths will be 2. Suppose if the number of parallel if it is lap wound, then this A will become number of poles. Understood? I will explain you in detail while studying about winding, okay, that lap winding and wave winding. So for time being you fix to that. So this is how the EMF is generated in DC generator. Okay, due to poles we are getting magnetic field lines, that is flux. These are poles. Then the conductor is rotated here in between the magnetic fields at a speed of n for a minute, called 60 seconds, and the conductor is denoted as Z. It is connected in lap or wave, called area of parallel path or parallel path. Okay, so we can write it as E is equals to phi p n Z by 60A. This is what you get. Okay, so first I'll explain you the formula, then I'll explain you the theory. This is how my teaching methodology works. Okay, you got to know how this generated EMF has come. See sir, you are getting a voltage, whether it may be generator or motor. You have this what V equals to E plus or minus IaRa. This is common for both DC generator and motor. See sir, if you are having a DC generator, this will become as a terminal voltage. then it will be generated EMF because it is a generator. Okay, then there will be a what, this is armature drop. This is the formula for DC generator. If you are talking about motor, this will be a applied voltage, then it will be in motor there will be a generating action. Due to that generating action there will be a EMF. That EMF we call it as a back EMF. So this will be a positive drop in the DC motor. Okay, this is the formula for your DC generator and motor. Understood? I'll explain you in detail while explaining you all the detailed concept. Okay, so let me firstly explain you how this DC generator is working. So see here, sir, I am considering a simple loop generator. This is constructed here. So consider it single turn. Okay, this is rectangular coil or copper coil ABCD rotating about its own axis in a magnetic fields, correct, north and south pole here, provided either permanent magnet or it might be electromagnet. So the ends of the coils are joined to a what, here two slip rings are there. Okay, so let me call it as A, and this we call it as let me call it as 1 and 2. Okay, so 1 and 2, we have two what, slip rings here, and for that we have connected brushes B1 and B2 which are insulated from each other from the central shaft. Okay, so two brushes on slip rings, that is B1 and B2, collects the current, okay, induced in the coil and gives it to the external load. It might be resistive load or inductive load or capacitive load or either of that or both or combined, RLC. Understood, sir? So here let me explain you one thing. So it has two main parts. Okay, rotating armature. Okay, here it will be in cylindrical form, and a stationary magnetic fields. Understood? So imagine the coil to be rotated in the clockwise direction like this. Okay, whenever this is rotating in a clockwise direction, as the coil is assumed in successive position in the field, the flux linked with it changes. The flux linked with it changes. Hence an EMF induced in the conductor, that is the generated or the induced EMF can be written as E is equals to N d phi by dt. Understood? There is a flux changes when linking with the conductor. Understood? So if the plane of the coil right angles to the line flux, okay, it is plane to the these flux lines, then the flux linked with the coil will be maximum here. Okay, at this position. So at this position, but the rate of change of flux is minimum, hence there is no induced EMF. So whenever the coil moves, okay, so it will be like this, then it will be like this. Okay, parallel or plane, parallel or horizontal to the flux lines, then flux links will be minimum, but the rate of change of flux will be maximum at 90. Understood? So when coil moves further to 180 degree electrical, flux link is maximum and rate of change of flux is minimum. So the induced EMF similarly at 270 degree will be maximum. Okay, but in the opposite direction. So this A, B, C, D will become here C, D, okay, and B, A. Understood? So here at the 360 degree we will get a 0 induced EMF. Therefore current in this simple loop generator will reverses its direction after every half cycle or half revolution. That is why it's called as alternative, but it keeps its magnitude constant. Here you can see its magnitude will be constant in both the direction. Understood? So for making the flow of current unidirection, because we are studying about DC generator, but the generated EMF or the induced EMF in armature core, it is alternating. We should get a DC output, that is unidirection voltage or EMF in the load side or output side is unidirection, that is DC. So in order to get that unidirectional current in the external circuit here. So what we are doing here, instead of this slip rings we are going to add split rings. Okay, these are called split rings. Okay, split rings, what they does, so here split rings are made up of conducting cylinders which is cut into two halves. Okay, it will be like this. Okay, so two halves. Here these two of split rings are insulated with mica. Okay, the insulating material which is used in split rings is called mica. Okay, it will be of thin sheet. Coils ends are joined to these segments on which rest carbon brushes are connected, that is B1 and B2. From here they will collect a current. Okay, brush position should be arranged so that change over segment B1 and B2 from one brush to other takes place when the plane of the rotating coil is right angle to the flux lines of flux where induced EMF in the coil is 0. Okay, so then split ring rectifies the alternating output into unidirectional and send it to the external circuit. Okay, in the every half rotation it is converting it into a unidirectional current. Okay, simply a DC generator is nothing but a synchronous generator plus a commutator. So here this commutator, what it is doing, this commutator is it is acting as a rectifier or a converter. In DC generator it is acting as a rectifier. Understood? It is converting alternating current into direct current. In DC motor it reverses. That's it. So you understood the working of this simple loop generator. So let me explain you what is the relationship between input power and output power in next class. Okay.